Okay, let's dive right into this explainer. Today, we're going to completely demystify that heavy, intimidating piece of metal sitting under your car's hood. I mean, for a lot of us, the engine is just this noisy mystery box that magically makes the car go forward, right? But stick with me, because by the end of our time together, you're going to understand exactly what's happening in there.
Here's our quick roadmap for today. First, turning fuel into motion. Second, inside the engine cylinder. Third, the four-stroke combustion cycle. Fourth, crucial supporting systems. And finally, delivering power to the wheels.
All right, part one, turning fuel into motion.
So let's start with the ultimate problem we're trying to solve here. How exactly do we move a 2-ton metal box down the highway at 60 miles per hour? We literally do it every single day without a second thought. You sit down, turn the key, or, push the start button, and the car just rumbles to life. But when you really pause and think about the sheer mass of the vehicle you're sitting in and how a simple flick of your wrist propels it effortlessly forward, it's actually staggering. That turn of the key kicks off this truly brilliant, highly synchronized sequence of physics and engineering designed to harness massive amounts of energy.
Most cars on the road today use what's called an internal combustion engine, or ICE. And honestly, the name itself gives away the secret here. It burns fuel inside itself. This is fundamentally different from an electric vehicle that runs on energy already stored in a battery. An internal combustion engine is hosting a literal, controlled chemical fire right inside its metal core. Its main job is to convert the chemical energy stored in your fuel into mechanical energy. When that fuel burns, it creates a rapidly expanding gas, and the engine's entire design is completely dedicated to capturing that violent expansion and turning it into a smooth, spinning motion.
Moving right along to part two, inside the engine cylinder.
Let's meet our core cast of characters. These are the components built to withstand extreme heat and pressure to make this magic happen. First, the cylinder. That's the main chamber where the pressure builds. Inside that chamber, you have the piston, which is a heavy block of metal that gets physically pushed up and down by the expanding gas. Up at the top, you've got the spark plug to ignite the fuel, along with two very important doors, the intake valve to let fresh air and fuel in, and the exhaust valve to let the burned, useless gases out.
Now, the real magic happens where the connecting rod links that flat, heavy piston down to the round crankshaft. It perfectly converts the piston's straight up and down motion into a rotating motion. Just think about how your leg pushes down in a straight line on a bicycle pedal, but that downward push makes the gears spin in a perfect circle. Well, the piston, connecting rod, and crankshaft are doing the exact same thing.
Which brings us to part three, the four-stroke combustion cycle.
Most car engines run on what's known as a four-stroke cycle. This basically means the piston has to move up or down 4 distinct times to complete just one full cycle of power production. And keep in mind just how incredibly fast this is happening. When you're cruising down the highway, this specific 4-step loop, intake, compression, power, and exhaust, is repeating up to 2,000 or 3,000 times a minute. That is dozens of times per second. Let's slow it down and break apart each stroke.
First up is stroke one, intake. As the piston moves downward in the cylinder, the intake valve opens up like a little trap door. This downward movement creates a powerful vacuum, physically sucking a perfectly measured mixture of fresh air and fuel right into the cylinder chamber. The engine is essentially taking a massive deep breath in.
Next, we move to stroke two, compression. Now that intake valve closes tight, completely sealing the chamber. The piston reverses direction and pushes back up, forcefully squeezing that fuel and air mixture into an incredibly tiny space at the top of the cylinder. We are talking about squeezing it down to 1/10 of its original volume. Why do this? Because packing all those volatile molecules so tightly together makes the eventual explosion vastly more powerful and efficient. Then comes the main event, stroke three, the power stroke. Right when the mixture is compressed to its absolute maximum, the spark plug fires. That tiny spark ignites the highly pressurized fuel and air, and the resulting explosion creates a violently expanding gas that has absolutely nowhere to go but down. It slams the piston back down with massive force. This single stroke right here is the only one that actually generates the power to move your car. And as a quick aside, if you drive a diesel vehicle, there isn't even a spark plug in there. The fuel simply ignites entirely on its own, just from the intense heat of that extreme compression. Pretty wild, right? Finally, we reach stroke four. Exhaust. The piston has been shoved to the bottom, and the chamber is now choked full of burned, useless smoke. So the exhaust valve at the top opens up, and the piston travels back up one more time. It acts just like a plunger, physically pushing those spent gases out of the cylinder.
This stroke is exactly what creates the exhaust fumes you see billowing out of your tailpipe on a cold winter morning. The chamber is now empty, the valve closes, and the engine is completely reset and ready to take its next breath of fresh air.
All right, part 4, crucial supporting systems.
So, containing hundreds of tiny, violent explosions every minute sounds chaotic and incredibly hot, doesn't it? Well, it absolutely is. That delicate 4-stroke cycle we just covered only survives because of a dedicated supporting cast working tirelessly behind the scenes. You've got the fuel system using advanced injectors to deliver impossibly precise amounts of fuel. You have the ignition system timing the spark to the exact millisecond. Crucially, you have the cooling system, which constantly circulates liquid coolant through the hot engine block to prevent a total thermal meltdown. And then there's the lubrication system. If the oil pump fails and stops pumping slippery oil between all those fast-moving metal parts, the intense friction will actually weld the internal components together, literally turning your complex engine into a solid block of melted scrap metal within minutes. And of course, the intake and exhaust systems are there continuously filtering incoming air and safely channeling away pollutants.
And finally, part 5, delivering power to the wheels. Okay, so we know exactly how the engine makes its power. But let's zoom back out and trace that energy all the way from the initial chemical reaction down to the rubber hitting the road. The whole journey begins at the very start of the intake stroke, drawing in the raw chemical potential of fuel and air. It's easy to forget, but a single gallon of gasoline holds an incredible density of energy, and this is the exact moment we begin extracting it. That highly potent mixture is sent right into the engine block for combustion. Through our rapid 4-stroke cycle, that dormant chemical energy is violently and loudly translated into raw physical force, punching those pistons aggressively downward.
Now, most cars don't just have one piston. They usually have 4, 6, or 8 of these cylinders. Because they're meticulously engineered to fire in a carefully staggered sequence, their individual downward punches hit the crankshaft one after the other in a rhythmic pattern. This brilliantly translates that chaotic, aggressive up-and-down punching into a remarkably smooth, continuous rotation.
That rotational energy then travels straight into the transmission. You can think of the transmission as the mechanical brain of this entire process. It adjusts the engine's rotational speed and torque to match exactly what you're doing on the road. If you drive a manual, you're acting as the brain. If you drive an automatic, the car's doing the thinking for you. Either way, the transmission uses lower gears to give you a strong, heavy push when you're accelerating from a dead start, and it shifts into higher gears for smooth, low-effort cruising on the highway.
Ultimately, that perfectly tuned, gear-adjusted power flows all the way through the driveshaft and the differential, projecting directly out to your wheels, pushing the entire 2-ton vehicle effortlessly forward.
So to wrap this all up, the crucial takeaway from this explainer is that driving relies on a truly beautiful, unbroken chain reaction. Your engine burns fuel to create expanding gas. That gas forces pistons downward, which turn a crankshaft. This happens in an endless, rapid-fire 4-stroke loop of intake, compression, power, and exhaust. The whole thing is kept perfectly balanced by vital cooling and lubrication systems, and finally, the transmission carries that rotating power right to the wheels.
It's incredibly easy to take our cars for granted as simple appliances that just get us from point A to point B. But the next time you turn that key and put your car in drive, I really hope you have a newfound appreciation for the incredible, fiery engineering happening thousands of times a minute right beneath your feet. Thanks for joining me for this explainer, and keep that curiosity alive.